Hello everyone, I am Purva Dev, a master's student from MIT Art Design and Technology University, Pune. It's truly an honor to discuss the topic urbanization and agriculture. I hope you are ready for an insightful journey into a topic that affects us all, whether we are in rural communities or cities. By 2050, more than 68% of world's population will be living in urban areas. Now let's pause and think. What does that mean? How will we grow our food? This isn't just a global statistic. It's a reality we are already experiencing right here in cities like Pune, where the pressure to accommodate a growing population is ever present. How do you think our rapidly growing cities impact agriculture? As urban areas expand, we face significant challenges that could reshape the way we farm forever. Urbanization is rapidly changing the face of agriculture. The growing population that drive urbanization demand more food, but traditional farming methods are struggling to keep up. Why? Because urbanization puts immense pressure on water, land and resources. Farming needs to evolve to fit into the new urbanized world, where every square meter counts. Think about Pune, a city expanding with each passing year. Land that was once used for agriculture is now transformed into buildings and roads. As the city grows, farmers are forced to either move far away or adapt to shrinking farmlands. But this isn't a problem only for Pune. It's happening all over the world. Urbanization brings both challenges and opportunities to agriculture. The challenges we will discuss later, but at the same time, this growing urban population gives us an opportunity to rethink how we farm and where we grow our food. Take Singapore for example, a place with very limited land available for the traditional farming, yet they've become a global leader in innovative farming techniques like vertical farming. By growing crops in the stacked layers inside the urban building, Singapore is using technology to maximize the food production in a minimal amount of space. This is a great example of how urbanization is pushing us to think creatively and come up with sustainable solutions. As cities like ours continue to expand, we must recognize the need to adapt agriculture to urbanization. We are standing on the threshold of our new agriculture revolution, where food production will need to be smarter, more efficient, and more sustainable. We need to ask ourselves how can we contribute to this change, ensuring that the future generations can thrive a world where cities and agriculture are in harmony. How many of you have seen farmland turn into city buildings? It's a sight we are all familiar with. Traditional farming is facing more challenges than ever before, especially as cities grow and rural areas shrink. Let's take a closer look on the key issues farmers are dealing with today. Firstly, land scarcity. With urban sprawl, there's less and less land available for agriculture. Farmers are losing access to arable lands as cities expand outwards. Land that was once fertile and productive is now covered with buildings, roads, and infrastructure. This land scarcity forced farmers to find new ways to grow food or relocate to areas farther from cities. Pest control. Urbanization disrupts ecosystem and one of the consequences is an increase in pest problems. As human populations grows, so does the need for pest management. But controlling pests in traditional farming settings become more complicated as urban areas encroach on the farmland. Climate dependency. Traditional farming is highly dependent on the climate, which is becoming increasingly unpredictable, and in cities the problem is compounded by urban heat islands, where the concrete buildings and infrastructure trap heat, making it harder for the crops to grow in surrounding areas. Farmers are left vulnerable to the unpredictable weather patterns, droughts and floods, all of which can devastate the crops. Water stress. Growing cities put tremendous pressure on the water resources. As urban areas grow, they demand more water, leaving less water available for the agriculture. Farmers often find themselves in direct competition with the cities for access to water, and this water stress can lead to lower crop yield and reduced food production. Labor shortages. As more people move from rural areas to cities, farming communities face several labor shortage, the workforce that was once readily available is now being pulled into urban industries, leaving fewer people to work in the fields. This decline in availability of the labor adds to the pressure already faced by the farmers. So what does this mean for the future of agriculture? How will we adapt to these challenges to ensure that we can feed the world's growing population in a sustainable way? But these challenges also present an opportunity for innovation and adaptation. We need to rethink how we will grow our food. What if I told you that we could grow fresh food without any soil? Sounds unbelievable, right? But this is already happening and it's called hydroponics. Hydroponics is a revolutionary method of farming where plants are grown without using soil. Using nutrient-rich water solutions, imagine fresh herbs growing right in the middle of a city on rooftops or even inside the buildings with no soil involved. But why is this important? Hydroponics helps us tackle some of the biggest challenges traditional farming facing today, like land scarcity and water stress. In cities where space is limited, hydroponic systems can grow food year-round in vertical farms or even in greenhouses using far less space and water than traditional methods. So let's reimagine how we grow our food. Hydroponics allows us to farm anywhere, anytime, and with minimal impact on the environment. How will you contribute to this exciting shift in agriculture? We've already talked about how this innovative system can grow food without using soil, but now let's get into the details of what makes plants thrive in such a system. Plants need more than just water to grow. Especially in soilless systems like hydroponics, the key to success is in the nutrient solutions which provide everything plants would typically get from the soil. Macronutrients. These are the heavy lifters, key elements like nitrogen, phosphorus, and potassium, which are absolutely essential for plant growth. They help in root development, flowering, and overall plant health. Micronutrients. While needed in smaller amounts, trace minerals like iron, calcium, and magnesium are vital for the plant's overall health. They strengthen the plant's immune system and help it grow robustly. Humic and fluvic acids. These are natural compounds that help plants absorb nutrients more efficiently. Think of them as facilitators of nutrient uptake, allowing plants to get the most of our solutions they are growing in. pH buffers. These help maintain the optimal acidity levels, ensuring the plants can properly absorb the nutrients from the water solution. Now you know that the plants can't survive just on water. These nutrient-rich solutions are what keep them healthy and productive in a hydroponic environment. Another key component in the hydroponic system is lighting. Without natural sunlight, we need to provide artificial light that mimics what plants would get outdoors. LED grow lights. These are energy efficient and commonly used for indoor farmings. They provide the right spectrum of light that plants need while consuming less electricity and generate less heat. Fluorescent lights. They are affordable and work well for the small scale or hobby growing, but they aren't as powerful or efficient for large scale hydroponics. High pressure sodium. These are the powerful lights often used in commercial setups, but they generate a lot of heat, so you'll need a cooling system to manage them properly. Each type of light has its own pros and cons, but in hydroponic systems, getting the right balance of light is just as important as providing the right amount of nutrients. So as you can see, hydroponics is not just about growing plants without soil, it's about creating an ideal environment for the plants by fine-tuning their nutrients and lighting. This system allows us to grow food anywhere, even in the middle of the city, while maximizing the efficiency. Hydroponics offers numerous benefits over traditional farming. Firstly, year-round growing. With controlled environments, we can grow crops continuously regardless of the weather or season. Space efficiency. Hydroponic systems use vertical spaces making them ideal for urban areas where the land is limited. Water conservation. Hydroponics uses up to 90% less water than traditional farming as water is recirculated. Pest and disease control. By growing indoors, we can better control the pests and diseases that could otherwise harm the crop in an open field. Despite of its advantages, hydroponics come with its own set of challenges, like high initial costs. Setting up a hydroponic system can be expensive due to the need for specialized equipments. Technical expertise. Successful hydroponic farming requires knowledge of both plant biology and system maintenance. Choosing the right hydroponic system. There are different types of hydroponic systems, each with its unique benefit. Deep water culture. Plants grow with their roots submerged in a nutrient solution. The nutrient film technique. A thin film of nutrient solution flows over the roots. Then EBB flow, also known as flood and drain. This system alternates between flooding the roots with nutrients and allowing them to dry. Wick systems, a passive system that uses a wick to draw nutrients to the plant roots. In an aquaponic system, fishes are raised in tanks where their waste rich in ammonia accumulates in the water. This waste needs to be removed to ensure healthy environment for the fishes. Here's where the nature steps in. Specialized bacteria convert the ammonia into nitrates, a form of nitrogen that plants need for their growth. The plants absorb these nitrates as nutrients, effectively cleaning the water in the process. After the plants filter the water, it is cycled back to the fish tanks, creating a closed loop system. This symbiotic relationship between fish, bacteria, and the plant ensures a sustainable, efficient system where both fishes and plants can thrive while minimizing the waste and resources use. This integration of aquaculture and hydroponics is a key innovation in the future of sustainable farming. An aquaponic system is made up of several key components that work together to create a sustainable closed-loop ecosystem. First, there are fish tanks, where fishes are raised and produce nutrient-rich waste. Next, the biofilters houses beneficial bacteria that convert ammonia in the fish waste into nitrates, which are essential for the plant growth. Then the grow beds or plant bed is where the plants are cultivated, absorbing these nutrients and purifying the water. Finally, there's a water pump and pumping system, which recirculates the clean filtered water back to the fish tanks, maintaining a healthy environment for both fishes and the plants. Each component plays a vital role in balancing the system and ensuring optimum production of both fishes and the crops. When selecting fish for an aquaponic system, it's important to choose species that are hardy, adaptable, and able to thrive in a controlled environment. Common choices include tilapia, known for their fast growth and tolerance of varying water conditions, and catfish, which are resilient and well studied to aquaponics. Additionally, koi and goldfish are popular options for smaller or ornamental systems. The key is selecting the fish that can both produce enough waste and support plant growth and thrive in the system's specific water parameters, ensuring a healthy balance of both fishes and the plants. Then the plant selection. In an aquaponic system, plant selection is crucial for optimizing growth and maintaining balance. The best plants for aquaponics are those that thrive in nutrient-rich water-based environments. Common choices include green leafy vegetables like spinach, which grow quickly and have relatively low nutrient demands. Herbs such as basil and mint also perform well. For more advanced systems with higher nutrient levels, you can cultivate fruiting plants like tomatoes and cucumbers. The plants you choose should align with the fish species and nutrient availability to ensure a healthy, productive system where both plants and fishes thrive in synergy. In an aquaponic system, nutrient cycling is the process that sustains both plants and fish growth in a balanced symbiotic environment. It starts with the fish producing waste primarily in the form of ammonia. Beneficial nitrifying bacteria in the biofilter converts this ammonia into nitrates and then into nitrates, a form of nitrogen that plants can easily absorb. The plants take up these nitrates as nutrients for growth, effectively cleaning the water. This purified water is then cycled back to the fish tanks, creating a closed-loop system where waste is continuously transformed into essential nutrients, ensuring sustainability and minimizing the need for external inputs. In an aquaponics system, regular monitoring and maintenance are critical for the ensuring optimal performance and health of both fishes and the plants. First, water testing is essential to monitor key parameters like pH, ammonia, nitrates and nitrates to maintain a stable environment for the fishes and the plants. Keeping the water balanced ensures that the nutrient cycling is functioning correctly. Secondly, the fish health should be observed regularly for signs of stress, illness, or unusual behavior, as the fish is central to the nutrient production. Thirdly, tracking the plant growth ensures the plants are receiving enough nutrients, and if any stunt or yellowing growth can indicate nutrient imbalances or water quality issues. Finally, the system cleaning includes the removal of debris, flow prevents blockages and maintains the system's overall efficiency, ensuring a healthy, productive aquaponics system. Aquaponics offers several key advantages like efficient water use. Water is recirculated, minimizing the waste. Sustainable farming. This system integrates fishes and plant production in a closed-loop, sustainable ecosystem. Increase yields. By maximizing space and resource uses, aquaponics can produce higher yields than traditional farming. Challenges of aquaponics. However, aquaponics is not without its difficulties. System complexities. Balancing the needs of both fishes and the plants require careful monitoring and adjustments. Specialized knowledge. Both aquaculture and hydroponics expertise are necessary for aquaponics. Initial investment. Like hydroponics, aquaponics requires a significant upfront investment. We have just explored hydroponics and aquaponics, but now let's dive into aeroponics, a truly cutting-edge technology in the world of agriculture. Aeroponics is a soilless farming technique where plants are grown in an air-based system and nutrients are delivered through a fine mist. This method is not only space efficient but also highly sustainable, making it a significant leap forward for urban farming and controlled environment agriculture. Unlike hydroponics, where the plants rely on the water to carry nutrients, aeroponics suspends the plant roots in the air, delivering essential nutrients directly via mist. The roots are sprayed with a nutrient solution in the form of a mist, which enhances the nutrient absorption efficiency and promotes faster growth. Key components of an aeroponic vertical farm. Now to understand how an aeroponic system works, let's break down the key components. Misting system. This system delivers a fine spray of nutrient solution directly to the plant roots, ensuring they receive the necessary nutrients for the growth without waterlogging. Air circulation. Adequate oxygen is vital. Good airflow ensures that carbon dioxide is supplied to the plants, which is necessary for the photosynthesis. Lighting systems. Similar to other vertical farming methods, aeroponics relies on artificial lights such as LEDs. These lights provide the optimal light spectrum for the plant growth, compensating for the lack of natural sunlight in the indoor environments. Growth chambers. These are enclosed spaces that maintain a controlled environment for the plants, managing humidity, temperature, and light for the optimal development. Nutrients used in aeroponics. Just like hydroponics, aeroponics requires a carefully balanced nutrient solution. Water, the base of the nutrient solution, critical for delivering nutrients through the mist. Nitrogen promotes foliage and stem growth, an essential element for healthy plants. Phosphorus supports root development and is key to flowering and fruiting. Potassium enhances plant vigor and increases resistance to the diseases. The combination of these nutrients ensures robust growth and higher yields despite unconventional growing medium. Now let's talk about the sustainability of this method. Aeroponic aligns perfectly with the modern agriculture demands for resource efficiency, renewable energy. Many aeroponic systems can be powered by renewable sources such as solar energy, reducing their carbon footprints. Water conservation. Since water is used only in the form of mist, aeroponic reduces water consumption up to 95% compared to traditional farming, making it ideal for regions facing water scarcity. Waste reduction. With precise nutrient delivery, minimum water runoff, aeroponic contributes to a reduction in agricultural waste. Benefits of aeroponics vertical farming. What are the real world benefits of aeroponic vertical farming? Let's explore. Increased yield. By utilizing vertical spaces and delivering nutrient directly, aeroponics can produce more crops in less time, maximizing the productivity per square meter. Reduced water uses. The controlled misting system uses significantly less water, making aeroponics one of the most water efficient farming methods. Improved pest control. The closed environment reduces livelihood of pests, minimizing the need for chemical pesticides. Environment friendly. With lower resource uses and sustainable energy options, aeroponics is an eco-conscious choice for the future farming. However, aeroponics isn't without its challenges. Let's break down a few critical issues. Power dependency. Aeroponic systems rely heavily on the electricity to run misting systems, lighting, and climate control. This makes them vulnerable to power outages. Plant vulnerability. Since roots are exposed in the aeroponic systems, plants can be more susceptible to the root diseases and pests if not properly managed. Maintenance and requirements, regular cleaning and system monitoring are essential to prevent the buildup of salts, debris, or bacteria which could harm the plant health. To overcome some of the challenges and increase efficiency, modern technological advancements have played a significant role. Sensors. These monitor environmental conditions such as humidity, temperature, and nutrient concentration, ensuring the system runs optimally. Automation. Automated systems reduce labor needs by controlling system schedules, lighting, and nutrient delivery, making the entire process more efficient. Data analysis. Farmers can use real-time data to optimize resource uses and improve crop performance, reducing the waste and maximizing the yield. Applications and use cases. Where is aeroponics being used today? Here are some exciting applications. Home gardens. Imagine growing fresh produce in comfort of your home, even with limited space. Aeroponics is perfect for urban dwellers. Educational institutions. Schools and universities are adopting aeroponics to teach students about sustainable agriculture and cutting-edge food technology. Commercial farming. Many large-scale farms are transitioning to aeroponics to supply high-quality, locally grown produce to restaurants and markets. Space exploration. NASA and other space agencies are exploring aeroponics to develop compact, self-sustaining systems for long-term space missions, providing food for astronauts and distant planets or during deep space travels. As we look towards integrating vertical farming into urban environments, it's essential to recognize that policies and regulations must adopt to support this innovation. One of the key areas of focusing is zoning laws. Urban farms, especially those using advanced vertical systems like aeroponics, are often subjected to local zoning regulations that govern where and how these farms can operate. These laws can impact everything from building height restrictions to land use designations. To fully harness the potential of vertical farming in cities, policymakers need to develop frameworks that encourage sustainable urban agriculture, while addressing issues like resource management, environmental impacts, and food safety. This evolution in policy will be crucial for fostering the growth of urban farming and making it a viable solution for the future food security. So these are some of the references used for the above presentation. I am grateful for your willingness to lend an ear. I appreciate your attention. Thank you.